All right, today we're going to talk about another method of solving quadratic equations. So we've done the square root method, we've done factoring, and today we're going to talk about the quadratic formula, which I think you will like. It's just a formula and it's pretty easy. So one thing I want you to remember though is that quadratic equations can have either 2, 1, or no real number solutions, and we're going to look at that. Those are options 2, 1, or none. Okay, and the situation where we would have none, if you remember, this is when we take the square root of a negative. And we'll encounter that today. Okay, so here's your formula. If you have a scenario where you have ax squared plus bx plus c equals 0, then you could factor this and do the zero product property. Or if it doesn't factor, this is the best way to go. Use this formula right here. B squared, or negative b plus or minus b squared minus 4ac all over 2a. Okay, so here's an important note here. Make sure that your quadratic equation is in standard form, which is how it looks right here. And then use the quadratic formula. So let's look at the first one here. So let's first start by putting this in standard form. I'm going to subtract 21 so that I have 0 on the other side. Alright, so let's go through and let's figure out what each variable is. A is the coefficient on x squared, which would be 1. B is the coefficient on the middle term, which is negative 4. C would be negative 21. Once you have A, B, and C figured out, you're just going to plug these values in to your formula. So x equals, now we have negative b, but our b is negative 4, so that becomes a positive 4. Positive 4 plus or minus the square root of b squared, which is negative 4 squared, minus 4 times a, which is 1, times c, which is negative 21. Okay, so I know it might be a little overwhelming, but just write everything down and we'll clarify anything tomorrow. Then we're going to divide by 2 times a, which is 2 times 1. Okay, here comes the hardest part, is just simplifying. So x equals 4 plus or minus, and let's simplify inside here. Negative 4 squared is 16, and then we're going to have minus 4 times negative 21, which will give us plus 84. And then we're going to divide all of that by 2. So underneath the radical here, I'm going to combine those two terms. So x equals 4 plus or minus the square root of 100 divided by 2. Now we all know what the square root of 100 is, and that's just 10. So I'm going to change this. I'm going to say x is equal to 4 plus or minus 10 divided by 2. Now once you get there, you're pretty much finished. There's just one more step. So you have two solutions. You either have x equals 4 plus 10 divided by 2, or x equals 4 minus 10 divided by 2, because of that plus or minus right there. So x is equal to 14 over 2, which is 7, or x is equal to negative 6 over 2, which is negative 3. So those are your solutions using the quadratic formula. Let's try another one. So let's put this in standard form first. Negative 3x squared minus 11x. And then I'm going to add 4 to both sides. So my quadratic equation is in standard form. Let's go through and identify our coefficients. A would be negative 3. B, negative 11. C, 4. So maybe take a minute, stop the video, and try to see if you can plug all of these values for A, B, and C in, and then I'm going to do it and you guys can check to see if you got it right. So using our formula, x is going to equal negative b, which is negative 11, which will give us positive 11, plus or minus the square root of negative 11 squared minus 4 times negative 3 times 4. All divided by 2 times negative 3. Okay, hopefully you plugged all that in right. Let's go through and simplify. So x is equal to 11 plus or minus the square root of 121, which is negative 11 squared. And over here we're going to have, this is going to turn out to be plus 48. So I'm going to add 48. Divide that by 2 times negative 3, which I'm just going to change that. That's negative 6. All right, keep simplifying. So I'm going to add what's underneath the radical here. So x is equal to positive 11. Positive 11 plus or minus the square root of 169 divided by negative 6. So x is equal to 11 plus or minus 13 divided by negative 6. So I have two options from here. I have x equals 11 plus 13 over negative 6, or x equals 11 minus 13 all over negative 6. So 11 plus 13 is 24 over negative 6, which would give us negative 4 as one solution. Or over here we would have, that's negative 2 over negative 6, which will give us positive 1/3. So both of those are your solutions. We'll talk it tomorrow how to check if your answers are correct. Okay, one more thing you need to know about the quadratic formula, and this is very useful, and I know this is a lot of information, but we'll have plenty of time to practice it. You need to know and use something called the discriminant. The discriminant is this expression that's underneath the radical, b squared minus 4ac. That is called the discriminant. So the discriminant can be three things. It can be positive, negative, or 0. And one of those, or each of those types tells us something about the quadratic. So let me just briefly go through here. If your discriminant is positive, that means that there are two real solutions. And that's going to mean that your quadratic crosses the x-axis twice. If your discriminant is 0, there is only one real solution. And that means it's going to cross your x-axis once for one real solution. And if your discriminant is negative, meaning less than 0, there is no real solution, meaning it doesn't cross the x-axis ever. So let's look at a couple examples here, and I've got sort of a reminder up at the top. We're going to identify whether these two quadratics here and here have either one real solution, two real solutions, or none. So let's put this in standard form. We've got 2x squared minus 3x plus 5 equals 0. Let's go through. A is 2, B is negative 3, C is 5. Okay, now the discriminant is b squared minus 4ac. So I'm going to figure out what that value is. B squared is negative 3 squared minus 4 times 2 times 5. So when I do this, I'm going to get positive 9 minus 40, which is going to give us a negative number. All right, I think everybody agrees with that. Negative 31 is less than 0. If the discriminant is negative, there are no real solutions. Your graph looks something like this. It's never going to cross the x-axis. Okay, let's look at the other scenario. A is 1, B is negative 6, C is 9. Your discriminant is b squared minus 4ac. So let's plug everything in. We've got negative 6 squared minus 4 times 1 times 9. So it's going to give us 36 minus 36, which ends up with 0. And 0 is equal to 0. If your discriminant is 0, then there is only one real solution. And if you want to visualize what's happening here, your graph is just hitting the x-axis at one point and then going off. Okay, we'll do more practice tomorrow.